All right, let's just get right into it. You've seen them in the movies, right? These terrifying cosmic monsters, lurking in the darkness, just waiting to suck up spaceships, planets, everything. But is that the real story? Are black holes actually the giant vacuum cleaners of the universe? Well, on the left, you've got the classic sci-fi villain we all know. But the reality, over on the right, is honestly so much cooler. See, black holes aren't space monsters. They're just gravity, taken to its absolute most mind-bending extreme. The truth isn't nearly as scary, but it is way more fascinating. So, let's pull back the curtain on these cosmic movie monsters, shall we? We're going to separate that Hollywood fiction from the incredible scientific fact. And to do that, we have to start with one single idea, an idea that pretty much explains everything about them.
And that one simple idea? It's gravity. But look, to really get black holes, you have to kind of rethink what you learned about gravity. It's not just some force pulling you down, it's actually the shape of the universe itself.
Yeah, you heard that right. Gravity isn't some invisible rope pulling on things. It's what happens when something with mass, like a planet or a star, literally bends and curves the fabric of space and time around it. I know that sounds weird, but a simple analogy makes it all click.
Just picture this. Space is a gigantic, perfectly flat, stretched-out rubber sheet. Totally smooth, totally even. That's our universe with nothing in it. Okay, now let's start putting some stuff on it.
If you put a bowling ball on that sheet, what happens? It makes a big dip, a big curve, right? Now, if you roll a little marble nearby, it's going to fall into that curve and circle the bowling ball. That curve, that's gravity. Our sun makes a huge curve that keeps the Earth in orbit. And the key thing to remember is this: the more mass you have, the deeper the curve you make.
So, what's a black hole in this picture? Well, imagine you have an object with so much mass squished into such a tiny, tiny point that it doesn't just make a curve in the sheet. No, it punches a hole right through it. It creates a pit so incredibly deep and steep that once something falls in, the walls are just too sheer to climb out. There's no escape.
So where do these unbelievable objects even come from? They're not just born out of nowhere. They're actually forged in the death of the most massive stars in the entire universe. It's pretty spectacular.
You know, for millions of years, a huge star is in this constant cosmic battle with itself. The nuclear fusion inside is pushing everything out, while its own massive gravity is trying to crush everything in. Well, eventually the star runs out of fuel. The pushing stops, and gravity wins. The entire star collapses inward on itself with unbelievable force, squeezing all of that material into a point smaller than an atom. And that collapse creates this boundary. It's called the event horizon. The best way to think of it is like the edge of a cosmic waterfall. If you're outside of it, you can still paddle away. But the second you cross that line, you've gone over the edge. The current is too strong. For a black hole, that current is gravity, and it's so powerful that to get out, you'd have to go faster than the speed of light. And well, nothing can. Okay, so even with all that, you might still be thinking, that sounds an awful lot like a cosmic destroyer. But this, right here, is where the whole story completely flips on its head, because it turns out these things aren't just endings. They're not destroyers. They're galactic architects.
Get this, scientists have discovered that at the very heart of pretty much every single major galaxy we've ever looked at, including our own Milky Way, there's a supermassive black hole. Not roaming the edges, not hiding in a corner, but right smack in the middle like a gravitational anchor for the whole show. And when we say supermassive, we are not kidding around. The black hole in the center of our galaxy, its name is Sagittarius A star, has the mass of 4 million suns. Just try to wrap your head around that for a second. It's an almost unimaginable amount of gravity in one place.
So we have to completely change our perspective. A black hole isn't some hungry predator on the loose. It's more like a cosmic anchor. The incredible gravity of Sagittarius A star is a huge reason why the billions of stars in our galaxy, including our own sun, are held together in that beautiful spiral shape we know. In a very real way, it helps hold our entire galactic home together. Okay, so now that we know they're architects, not monsters, let's just go ahead and bust those last few movie myths once and for all. Let's do a little rapid fire. Myth, they're vacuum cleaners. Reality, nope. If our sun magically turned into a black hole with the same mass right now, we wouldn't get sucked in. We'd just keep orbiting like normal, except it would get very, very cold. Myth, they roam around eating things. Reality? Nah, they just follow the laws of gravity. They only eat stuff that strays way too close to their event horizon. And finally, myth, they're holes. Reality? They're not empty. They're objects, just incredibly, unbelievably dense ones. So we've swapped the movie monster for a galactic architect. But what's at the very, very center, at that tiny point of infinite density? The honest answer is we don't know. Our understanding of physics, of reality itself, just breaks down there. And you know what? That's probably the most exciting part of all. Black holes represent the edge of human knowledge, a place where the biggest mysteries of the universe are still waiting for us. And science absolutely loves a good mystery.